Welcome to VM by C channel. Today we are going to discuss fourth chapter of the Vedic Maths book of Swamiji. In the fourth chapter, we are going to discuss divisions by using nikilam method. Nikilam means nikilam navataha charmam dashataha. In English, we can say that all from 9, last from 10. So that is the sutra we are using in the divisions. This is a special case. Already we are dealt with nikilam navata charmam dashataha in multiplication chapter. Now we are going on to divisions. Okay. So first of all, Swamiji took 2-digit dividend and a divisor as 9. First of all, if you understand how to divide with 9, later we will discuss everything regarding this division concept. So when we have the divisor 9, simply Swamiji is saying that divide the dividend into two parts. One will be remainder part, another will be quotient part. How we can divide that? From the unit place digit and the remaining digits. Those are two parts. Suppose we have 12. So unit place digit is the one part and the remaining digit will be one part. Suppose 123 we have. So I'm talking only when we have the divisor 9 only. So remember that point. So unit digit is a one part and the remaining digit is a one part. So unit place part indicates the remainder and the remaining part is indicates the quotient. Suppose 1, 2, 4, 7 is there. We are dividing into two parts. Unit place indicates remainder and this part indicates the quotient. I hope you understand. When we have the divisor 1, why we are dividing like that, I will tell you later. Okay. Just you observe how we solve the problem. So after dividing into two parts, first of all, we drop the digit as it is. That is 1. This 1 is added to the next digit of the dividend. That is 2. And 1 plus 2, that is 3. Now this will be our remainder and left part will be our quotient. In the same way, you can see in the third problem also. First, we are dropping 3 and this is the quotient digit now. This quotient digit added to the next digit of the 3 in the dividend. That is 3 here. So if you add this 3 to dividend digit, then we are getting 6. So here right part indicates the remainder and the left part indicates the quotient. And if you see the fifth problem also, in this case, first we are dropping 5. Now 5 is added to the 2. So then we are getting 7. Now 7 is the remainder part and 5 is the quotient part. So remaining problems, everything will be, we can solve like that. In this case, we are taking only 2-digit dividend. Okay. Now let us see 3-digit dividend here. Look at now. Now okay, in this case, we are taking 3-digit dividend. Okay, 3-digit. So 103 divided by 9 is there. First problem, you can see. So unit place digit is the one part and remaining digit will be another part. So we are dividing into two parts. One will be left, another will be right. So first of all, what we have to do when we have the divisor 9, then simply drop the first digit. That is the first quotient digit. This first quotient digit added to the next digit of the 1 in the dividend. So I'm adding here so that I'm getting again 1. Now new quotient digit 1 is added to the next digit of the 0. that is 3 in the dividend, we are adding to that number. Okay. So that we are getting 4. Now this is the right part indicates the remainder part and the left part indicates the quotient part. I hope you understand. In the same way, if you see the third problem, 124 divided by 9. First we are dropping 1. This one added to the 2. Then we are getting 3. 3 now added to the 4. Then we getting 7. So 7 is the remainder and 13 is our quotient. If you see the sixth problem, here we are dropping 3. 3 added to the 1. So then we are getting 4 in the quotient and 4 is added to the 1. So then we are getting 5 in the remainder part. So this will be the remainder and this will be our quotient. Let us discuss some more examples. So remaining same way you can solve it for the practice. Now in this case, let me discuss some more problems with the same divisor 9, but dividend little bit high, larger numbers. So 1, 2, 0, 3, 1 divided by 9. So when we have the divisor 1, first digit we are taking as a one group and the remaining digit as a 1. Okay. Now first of all we are dropping the 1 here. We are dropping the 1 and this one is added to the 2. So that we are getting 3. Now this 3 added to the 0. Then we are getting 3 in the quotient and this 3 added to the 3. So that we are getting 6 in the quotient. So 6 is added to the 1. Then we are getting 7 in the remainder part. Now 7 is our remainder part. 1336 will be our quotient part. If you take the third problem, 1, 2, 0, 0, 2, 1 and 2. Okay. So two groups here. So first of all, we are dropping 1 and 1 is added to the 2. So that we are getting 3. 3 is added to the 0. Then we are getting 3 and 3 added to the 0. Then we are getting 3. Now 3 added to the 2. Then we are getting 5. 5 is added to the 1. Then we are getting 6. 6 is added to the 2. Then we are getting 8. So 8 is our remainder part and this left part totally indicates our quotient. Okay. So I hope you understand very clearly. Come to this example. 18 divided by 9. In this case, if you see, we are dividing into two parts and first we are getting quotient is as a 1 and 1 is added to the 8, then we are getting 9. So we can directly say this is the remainder and this is the quotient. Okay, so far. Okay, but it is not a correct. Why I will tell you that. And in the second example also 125 divided by 9. So true I am dropping and 2 is added to the 2. So I am getting 4 in the quotient digit. 4 is added to the 5. So I am getting 9 in the remainder. So here 9 is remainder and 24 is our quotient. If you see in the fourth problem, 2 is dropped, 2 is added to the 3. So then we are getting 5. 5 is added to the 7. Then we are getting 12. So 12 is the remainder and 25 is our quotient. Okay. But what happened here? Every time in the divisor, every time in the division, okay, the remainder is the same or greater than the divisor. So this is not permissible. Means remainder is always less than the divisor. But if you see here we got 9, here we got 12. If you see these two examples, remainder is equivalent to the divisor and remainder is greater than to the divisor. So it is not acceptable in the division procedure. So that Swamiji is saying that when we have remainder is equal to the divisor and a remainder greater than to the divisor, in that case, again, take the remainder and divide this number by the divisor. So that we are getting 1 is the quotient and 0 is the remainder. So we can say that this is the remainder part, this is the quotient. So this is the quotient number. So that is the quotient number we are adding to the previous quotient number, so that we are getting 2 as a final quotient number. In the second example, if you see, here also we have 9. So 9 divided by 9, then we are getting 1 and 0 is the remainder. You can say 0 is the remainder. This new quotient is added to the previous quotient, so that totally we are getting 25 here. In this case, 10 we have. So 10 divided by 9. So one time it will be gone. So 1 is the remainder. So 1 I am adding to the 1, and quotient digit 1 is added to the previous quotient, so that we are getting 15. Here we have 12 as a remainder. So divided by 9. So one time it will be gone. So 3 is the remainder. So 3 is no final remainder. New quotient digit added to the previous quotient number, so that we are getting 26 as a our quotient. So what you understand? Whenever remainder less than the divisor, then directly it will be answer. In case it will be equal to the divisor or greater than, sorry, equal to the divisor and greater than to the divisor. In that case, you have to divide the remainder by the divisor once again. This is a one approach. Okay, right. But Swami is saying that directly without division, you can apply again nikilam concept on it. Then you will get to the answer. Suppose 136 is divided by 9 is there. So when we have the 9 unit place digit and the remaining part we are dividing into 2. Am I right? So 1 we are dropping, 1 is added to the 3. So then we are getting 4. Now 4 added to the 6. So then we are getting 10. Now here you observe very carefully, 10 is more than the divisor. So again apply same concept. Unit place and the remaining digit are divided into 2 parts. Okay. Now first drop the 1 and this one added to the next number, then we are getting 1. So this will be our remainder part. Already we have the 14 here and the new quotient we are adding here, so that 15 will be our quotient part and the remainder will be 1 here. Let me take here third example. Try second example. Okay, 1 0 1 1 6 4 9 divided by 9. So this will be our first part and second part. Okay, right. First I'm dropping 1 I'm adding here, then I'm getting 1 again I'm adding here, then I'm getting 2 is added here, then I'm getting 3 is added here, then I'm getting 9. So 9 is added here, then I'm getting 13. See, observe very careful. We got here 3-digit number. This is also new for you. Okay, right. So now 13 is added to here, so that we are getting 22. If you observe very carefully here, 22 is more than the divisor, so that again we are applying the which concept? Nikilam concept. So first we are dropping 2 here. This is 2 is added to here, so that 4 will be the our remainder part. But this new digit is added to the previous quotient. But in the previous quotient, if you observe very carefully, here whatever tick mark will be there, there all the digits will be single digit, but this is the 2 digit. So first we are taking 3 and the extra digit will be carried forward, so that it will be 10. How much it will be? 10. So I'm taking 0 and this one again carry to the next number. Then I'm getting 4 and the next will be 2, 1, 1. So 1, 1, 2, 4, 0, 5 is my quotient and the remainder will be here 4. So this is the correct way of solving. Suppose 8, 4, 3 divided by 9. Let me take. This is my own example. So 8, 4, 3. Okay. First we are dropping 8. 8 is added to 4. Then we are getting 12. Okay. Let me change the question and let me write 7 here. Okay. 7 also. Right. Now 12 is added to here. Then we are getting 15. So 15 is added to here. Then we are getting 22. So again we are dividing this part by nikilam method. First we are writing 2. So 2 is added to 2 here. So 4 is our remainder part. So this value place. Now see, observe very carefully. 5, Extra number is carry forward. Totally 13. So 3 I am writing and this one will be carry forward. Then I am getting 9. So 937 is my quotient digit and the remainder will be here 4. Now I hope you understand very clear. Okay, right. And in the next section, Swamiji giving the some small hint here. When we have the divisor like 8, 7, 6, 5 like that, then also we can use the same concept, but small change will be there. That is the change is Swamiji explained here. So 23 divided by 8 is given. 23 by divided 8. First drop the 2 here. First we have to drop the 2. So these two we are adding to the 3, but before that you have to double the 2. We have to double the 2. What is the double the 2? That is 4. That is the 4 we are adding here. So that we are getting 7. Now it will be remainder and this will be the our quotient. When we have the divisor like 7 we have. First we are dropping the 1. Now this one added to the 3. But before this one is multiplied 3 times. So that we are getting 5 as our remainder part and 1 as our quotient part. When we have the 6, first we are dropping the 1. Now 1 is 4 times multiplied. After that added to the 1 here. So that 5 will be the remainder and the quotient will be 1. Why it is happening? Simply Swamiji is saying that already he told that here we are using nikilam navata charmam dashata. Nikilam navata charmam dashata means all from 9, last from 10. Suppose 9 is a single number is there. If you apply nikilam navata charmam dashata, so only single digit is from 10. If you subtract here, so then 1 will be the our nikilam navata charmam dashata value. For 8, it will be 2. For 7, it will be 3. For 6, it will be 4. Okay. In the 9, we are using this number. We are using this number. This number is called modified divisor here. So we are actually dividing with 9. But nikilam navata charmandashas when we are using, instead of 9, we are using 1. That is the reason in the divisions also we are adding. That is the point you have to note it. When we have taking the 8, all from 9, last from 10, that means 2 will be the modified divisor. Okay. In case 8 will be divisor is there as it is, then you have to subtract. But when we are taking its complement, that is the reason in the nikilam method we are adding. Okay. For 7, 3. In other words, this 9 nearest to 10. Okay. This 9 is nearest 10. So what is the difference between 10, 9, 3? That is 10, 9, 9. That is 1. This is number also nearest to 10. So difference will be 2. And this number also nearest to 10. The difference will be 3. And this number also nearest to 10. Then difference will be 4. In this way also we can say that. I hope you understand. Okay. Let me discuss some more examples, different examples. Now in this case, Swamiji taking 2-digit divisor. So 89 if you see, if you use all from 9, last from 10, then if you use this formula, then the complements will be, okay, complements will be first number from the 10, then you are getting 1, next number from 9, then you are getting 11. So this is the 11 we are using instead of 89. So that is the reason in the division we are adding. In other words, 89 is very nearest to 100. Okay. If you see the difference, that will be 11 here. That will be 11 here. Okay, clear? Right. So remember another point also I'm mentioning. Compare with the base number. This is the less. Less minus negative. So in the division we are already doing the subtraction. This number is the negative. So negative into negative becomes plus. So that is the reason we are adding here in the nikilam method. Okay, clear? Suppose 103 is my divisor. Then 100 will be the my base number at nearest to the 103. Then you are taking 3. It is a positive. Why? Because this is the divisor is more than the base number. Then in this case you can subtract. But in this case it's less than the base. So it is negative. Already negative divisor we are taking. In the divisor, we are subtracting. So negative into negative will be positive. Okay. I hope you understand. Okay. Right. So come to the Swamiji example. So first question 1 divided by 89. Okay. Now see 89 complement from the 100, that will be 11 is the modified divisor. Okay. Modified divisor. How many digits is containing? 1, 2. Now in this example, first two digit we are taking as a group and the remaining digit will be another. Suppose 1, 2, 3, 4 divided by 89 if I am taking. So modified divisor will be 11. So two digit we have. So 1, 2. After that, remaining digit will be one group. First two digit will be one group. In this way, we have to divide the numbers for the quotient and the remainder. Right. First of all, see, first two digits we have here two digits. So two digits we are taking. Now, first of all, we have to drop the 1 here. Okay, we have to drop the 1. So this one is multiplied with first one, and we are writing below the 1. You can see the arrow. Now, again, this one is multiplied with another 1. So 1 into 1 is 1, is we are writing below the next one. So all ones are completed here. Everything is we are reached to the end point. So whenever you reach to the end point, just simply add it. So 1 plus 1 is 2. Here also 2. So now 22 is the remainder and 1 will be the our quotient. Okay, slowly we are going, then you can easily understand. So here 111 divided by 73, it is 27 less than the 100. 100 having two zeros na. So first two digit we are taking as a one group. Otherwise, we have two digit in the modified divisor. So first two digit will be the one group. In the previous example, 9 we are taking. This is nearest to 10. Only 1 0 we have. First one digit we are taking 1. Or if you take the complement is 1, complement having only one digit. So that is the reason we are taking unit is as a 1. Only unit digit. Now first we are dropping this one. After that, observe very carefully 1 into 2. We are writing below the 1. So 1 into 7, that is 7. We are writing the next digit below. So that here it 8 and it will be 3. And 38 is our remainder part, 1 is our quotient part. So here 1, 2, 3, 4, 1234 divided by 888. So 888 complement, it is nearest to 1000. So 3 zeros we have, first to 3 digit will be the one group. That is the one way to separate. Another way is if you see the complement, first digit from 10, second digit from 9, and the next digit from 9. So it is also having 3 digits. So after first we are taking 3 digit as a 1. Okay, right. Now first of all we are dropping the 1 here, whatever number will be there. So 1 into 1, that is 1, we are writing below the 2. 1 into 1, that is 1, we are writing below the 3. 1 into 2, that is 2, we are writing below the 4. So this will be 6, and this column will be 4, and this column will be 3. So quotient will be 1, and the remainder will be here 346. Okay, I hope you understand very clearly now. Right. Now let us see some more examples. You can see some examples given here. Let me choose 1, 2, 3 examples from every type. Okay, right. So if you see the fourth question, first we are dropping the 1. Already we are written here complements. So that let me write here 1, 2, 3, 4, 5. And 8, 8, 8, 8 is a divisor. Okay, right. Observe very carefully. Complement 1, 1, 1, 2. This is our modified divisor. Having 4 digits. So 1, 2, 3, 4. So this will be our remainder part and the quotient. First we are dropping this one. So 1 into 1, 1, 1 into 1, 1, 1 into 1, 1, 1 into 2, that is 2. I am talking about this one. So finally 3, 4, 5, 7. So this is our remainder part and this will be our quotient part. Okay, and the remaining everything will be same way you can solve it. And if you see the 10th problem, let me discuss about 10th problem. 1111 divided by 89. Okay, 89. So 89, if you write the complement of this number first of all, then we are getting 11. Okay, 1 1 1 1. 11 having two digits now, so after two digits we are dropping the vertical line for remainder part and the quotient part. First we are dropping this one, observe very carefully. First we are dropping this one. Okay, now here 1 into 1, that is 1, I am writing below the 1. So 1 into 1, that is I am writing the below the next number. Over. After that, there is a no digit in the modified divisor. So you have to stop the procedure there by multiplication procedure. Whenever it is completed, add the next column. Add the next column. So that we are getting here 2. Okay, we are getting 2. When you are stop the procedure until we reach the last digit. Until that same procedure we have to repeat. Now see very carefully. Okay, we new digit we got na. So the new digit will be, look at now. 2 into 1, that is 2. See, here I am writing. So 2 into 1, that is 2. I am writing the next one. See, this is the first step and this is the second step. Okay. So see, observe very carefully. I reached here now. So now I can stop the procedure. Okay. So totally I have 4 here and 3 here. So 43 will be our remainder and the 12 will be our quotient. Okay. Let me take this one. 10013. After two digit, we are dropping the line. Why? Because 89 having two digit in the modified divisor. First, we are dropping the 1. Observe very carefully. 1 into 1. 1. 1 into 1. 1. Complete. This is the first step. Complete. Okay. Now, we are not reached the last place now. So, we are adding here. After that, we are getting 2. Now, see. 2 into 1. 2. 2 into 1. 2. Still, I am not reached the next procedure. So, let me add the next digit again. So, I am getting how much here? 3. So, 3 into 1 is 3. 3 into 1 is 3. Now, see, I reached the last step. So, finally, I am getting here 6 and 6. So, 66 is my remainder and the quotient will be 123. Okay. I hope you understand. Let me discuss 12th example. 1, 2, 3, 4, 5. My divisor will be 882. Okay. Sorry, it is not 882. I think so. It is 888. Okay, 888. Then only you will get 112 as a modified divisor. Okay, right. First we are dropping 1. Now see, 1 into 1, 1. 1 into 1 is 1. 1 into 2 is 2. Okay, it is clear? Now, we have to drop the next column, sum. That is 3. 3 into 1 is 3. 3 into 1 is 3. 3 into 2 is 6. Now observe very carefully. Here it will be 11. So 3, 2, 5, it is 9. And here it will be 7. But in this case, we got two digits. So first write 1. If you add this one to the next number, then it is totally become 10. Okay. So that 10, in the 10, we are taking 0 and the next number adding to the next one. That will be 8. So this will be our remainder part and the 13 will be our quotient part. In the quotient also same is it clear or not? Yeah. Let me take some more examples here. Okay. Right. Look at now. Let me talk about 13 example. So 2, 1, 0, 0, 1, 2. So divisor will be here 8, 9, 9, 7. So this number very nearest to 10,000. Huh? So complement 1, 0, 0, 3. So 4 digit. After 4 digit 1, 2, 3, 4. So this will be total remainder. Okay. Right. Now observe very carefully. First we are dropping 2. So 2 into 1, that is 2. 2 into 0, 0. 2 into 0, 0. 2 into 3, that is 6. Okay. Now we are dropping this column. We are getting 3. 3 into 1 is 3. 3 into 0, 0. 3 into 0, 0. 3 into 3, that is 9. Now here we are getting 11. One we are direct carry forwarding. Then we are getting 8. In this case 0 and 3. So this will be our remainder part and 23 will be our quotient part. Okay, is it clear? And any different value will be there. Let me see that. Here also it will be very easy. We are dropping 3. So 3 into total number if you multiply, then we are getting this part. And again, you can see again we are getting 3. 3 into 1 is 3. 3 into 0, 3 into 0, and 3 into 2, that is 6. So there is a no any change here. So this is also same example. This is also same. This is also same. This is also same. Yeah. Let me discuss here 22 example. So 9, 9, 9, 7, 9. 1, 1, 1, 1, 1, 1, 1, 1. So complement from 10. 1, 9, here 0, 0, and a 0. So totally 5 digits. So 1, 2, 3, 4, 5. Okay. Now see. First we are dropping 1. So 1 into 0, 0. Next 0. Next 0. 1 into 2 is 2. 1 into 1 is 1. Is it clear? Now, next to column sum will be here 1. 1 into 0, 0. 1 into 0, 0. And the 2 and a 1. Here sum will be 1 again. So 1 into 0, 0. 1 into 0, 0. 1 into 0, 0. 1 into 2 is 2. And 2 into 1 is 1. So that 1 we are getting. In this column 3. Here it is 4. And here it is 4. And here it will be 2. So this will be our remainder part. And 113 will be our quotient part. Let me discuss here 23 example also. 88 is my divisor and my dividend 1, 1, 0, 0, 1. So if you see the modified divisor, that is 12 we have. So only 2 digits now. After 2 digits, we are dropping the line. So here first we are dropping the 1. So 1 into 1 is 1. 1 into 2 is 2. Is over. Next we are dropping 2 here, the sum this column. 1 into 1 is 1, sorry, 2 into 1 is 2. 2 into 2 is 4. So that in this column we are getting 4. Yes. So 4 into 1 is 1. And 4 into 2 is 4. So 55. You know, not. Oh, sorry. I did wrong. Sorry. So what is that here? 4 into 1 is 4. 4 into 2 is 8. Okay. Now here it will be 8 and the 9. So 89 is our remainder and 124 is our quotient. Okay. Let us discuss some more examples here. Right. So come to this example, observe very carefully. Example 24. So 2, 0, 1, 3, 7. Divisor will be 9, 8, 1, 9. Here, if you write the complement, okay, you write the complement from 10, 1, from 8, okay. Next it will be 1, next it will be 0. Okay. Now observe very carefully. First, we have the 4 digit. Now after 4 digit, we are breaking into two parts. Okay. First, we are writing 2. So 2 into 0, 0. 2 into 1 is 2. 2 into 8 is 16. And 2 into 2 is, sorry, 2 into 1 is 2. I already told you. First, we are getting 9 here. Here, totally 18 we are getting. Sorry, 19. So 19 we are getting. So just you write the 9. And extra digit will be carry forward. Are you getting my point? Yes or no? Previously also I explained this one. So this one if you added here, so that we are getting 4 and 0. So this will be our remainder part and this will be our quotient part. That is a simple thing Swamiji explained here. Okay. Yeah. Right. Let me discuss another example here. Right. Here, look at now. Double 8 modified divisor will be 2 and 198 is our dividend part. Okay. First, we are dropping the 1 here. So 1 into 1 is 1. 1 into 2 is 2. So that we are getting 110 here. I already told you remainder must be less than the divisor. So one way is divisor, you can divide it by 88. Then also you are getting the answer. And another approach Swamiji given, again you can apply the nikilam method. So in the divisor, we have the 2 digit now. So take first 2 digit and again you group it in the previous way. So first we are dropping 1. 1 into 1 is 1. 1 into 2, that is 2. So 22 is our remainder. And this new coefficient is added to the previous coefficient. So that we are getting 2. So 2 is our new coefficient value. I hope you understand. That is the simple thing Swamiji was explained here. Okay. Single step I explained you. Right. Come to this example. 8, 9, 9, 9, 7. If you, this is the divisor. If you write the complement of this number, first number from 10, that is 3. Next from 0. Next from 9, 0. Again, next from 9, 0. Next from 9, 0. Next number from 9. Then it will be 1. That is our modified divisor. And the coefficient will be 1, 2, 9. So not coefficient, dividend, sorry. 5, 4, 5, 6, 7. So we have the 5 digits. So after 5 digits, you can drop the line. So first we are writing 1 here. 1 into 1 is 1. 1 into 0 is 0. 1 into 0 is 0. 1 into 0 is 0. 1 into 3 is 3. So next we are dropping this one. Why? Because I am not reached to 7 now. Okay. Until that we have to repeat the same procedure. Na? So in this case, if you see, I am getting 3. So 3 into 1 is 1. Sorry, 3. 3 into 0, 0. 3 into 0, 0. 3 into 0, 0. And next one will be 9. So I reached the last place. So just we can add everything here. So 12, 4. And you can see here 15. 16. 1 will be carry forward. 10. 1 is carry forward. 6. But if you see, this is the more than the divisor. So again, we have to apply nikilam sutra on it. So 5 digit, you can see we have in the modified divisor 5 digit. Na? So 1, 2, 3, 4, 5. So here you can break down. So first we are writing 1. So 1 into 1 is 1. 1 into 0 is 0. 1 into 0 is 0. 1 into 0 is 0. And 1 into 3 is 3. So that 3, 4, 6, 0, 9 is our remainder part. And this is the new quotient added to the previous quotient. So that our quotient is 14. Quotient is 14. Okay, it is clear for you. So you can try this 27 for 1 and let me explain you 28 here. So modified device is written and every procedure will be clearly written. First we are dropping 1. So 1 into 0 is 0, 0, 0, 1 into 2 is 2 and 1. Next we are dropping again this column, then we are getting 1. 1 into 0 is 0, 1 into 0 is 0, 1 into 0 is 0, 1 into 2 is 2 and 1 into 1 is 1. Next, we are dropping this column. Again, we are getting 1. 1 into 0, 0. 1 into 0 is 0. 1 into 0 is 0. 1 into 2 is 2. And 1 into 1 is 1. Now, we are reached to the last place. You can see. Now, just we are adding each and every column. So that we are getting how much here? 1, 0, 1, 5, 0, 2. This is we are getting. But this is more than the divisor. So, we have the 5 digits in the modified divisor. So after 5 digits, we can drop the line here. Okay. So first digit we are dropping here. Okay. So 1 into 0 is 0. 1 into 0 is 0. 1 into 0 is 0. 1 into 2 is 2. 1 into 1 is 1. So after adding all these things, this will be our remainder part, and this extra new quotient is added to the previous quotient, so that will be 1 to our new quotient. Okay, is it clear? I hope you understand very clear. Now this is, look at now, why Swamiji took this problem. So far we have solved the problem which are very nearest to the base number. Am I right? But in this case, Swamiji taken 23. It is a 2-digit number and it is taken to the base 100. Then only we can write 77. If in this way, if you solve it, it will be, you can see here how much lengthy it is become. Okay. So let me explain you that also, so that you can understand how to use the nikilam formula and where to use the nikilam formula. Question 1011 divided by 23. So deviation is 77 written. So 2 digit we have. After 2 digit, we can drop the line here. Okay. First of all, we are writing 1 here. So 1 into 7 is 7. 1 into 7 is 7. We can drop right like that. After that, we are getting 7. So 7 into 7 is 49. Na? So Swamiji writing this 49 to here. Why? Because this number will be carry forward to the next place. So that is the reason he given little bit gap actually. Or let me write here very clearly so that you can understand how to solve it. Huh? So 1, 0, 1, 1. Okay. 77. Right. First 1 into 7 is 7, 7. Next we are taking 7. 7 into 7 is 49. You can see. 7 into 7 is 49. After that it will be 0 and the 1 will be carry forward. Why? Okay. Now this is a totally 5. We cannot write directly 5. Why? Because 2 digit we cannot place it. Na? So that suppose if you write 50. Okay. Total this is the 50. And in this case you are getting a 17, that means 57 you are getting. Then also see 0 and this will be again carry forward 620 you can. So this is a 2-step solution. A 1-step solution will be 0 and this 5 is added to here. So totally 22 we are getting and the 2 will be again carry forward 62. So 620 will be the remainder. But our divisor is how much? Only 23. So it is not acceptable. So again it is divided into same way. Okay, so now here first we are dropping 6 here. Okay, we are dropping how much? 6 here. It's not 4, actually it is 6. Okay, we are dropping 6 here. 6 into 7, 42. 6 into 7, 42. After, in the same way, if you solve it, then you are getting how much? See, this one will be 0. 3 will be carry forward. Then we are getting 9. So 390 we are getting. How much? 390. So this quotient is added to the this part. Then we are getting this. Okay. Again 319 is more than the 23 divisor. So again we are dividing. First we are dropping 3. 3 into 7, 27, 27. Okay. After all these things, how much we are getting? You can see 252. So this 3 is added. Sorry, this 3 is added to here. Okay. Are you getting my point? So in this case, if you solve, how much lengthy it is? Am I right? Yes or no? Even though if I explain like do, it will be take so much time. So this way of problem also we can solve very easy by using small trick. Not trick, small method. See, same problem Swamiji took here. Swamiji, what he is doing here? Anurupena Sutra is used. Anurupena means he changing the divisor. What is being changing the divisor? How is changing the divisor? 1011 divided by 23 is there. Okay, 23. So this 23 now is multiplying by 4, then it is become 92. So when we have the 92, it is very nearest to 100. So we can easily divide it. So 92 deviation will be here 08 and 1011 we are getting. After 2 digit we are dropping the line. And observe very carefully, we are dropping 1. 1 into 0 is 0. 1 into 8 is 8. Next we are dropping 0. So 0 into 0, 0. 0 into 8 will be, again we are getting 0. So 91 we are getting. Is it clear or not? Now see, quotient will be here 10 and the remainder will be 91. Here observe very carefully. Here 91 is more than the 23 actually. So you can have to divide it again. In two ways we can divide. I already told you. One way is normal division. Another way is, again we can apply nikilam navata charmam dashata. Is it clear or not? So first 2 digit we are taking as a one group. Okay. Then we are taking the 0. If you solve it here in the nikilam method, same result will be came out. So that is the reason the best way is only you have to divide it by 23. So 3 times you can take, that is 69. So if you subtract, then you are getting 22. So 22 is my remainder. And this new quotient is added to the here. But let me explain you once again very clearly. Okay, don't worry. Because important point here I am going to discuss. What is the important point here? This solution, this is the solution for the 92, not for the 23. So if you make it for 23, then how much you multiplied in the denominator? That is by 4. Sorry, into 4. So the same thing you have to multiply here. Then it is 40. Now that 40 is added to the new quotient. So 43 will be my quotient and remainder will be 22. Is it clear or not? Let me explain once again. Before adding the new quotient to the previous quotient, this previous quotient is related to the 92, not for 23. Or if you make it 23, how much you multiplied here? 4 times. That 4 times must to be multiplied to the quotient. And it is 40. Now you have to add new quotient digit to here. Then it will be correct answer. See, same question we are solved previously. How much lengthy it is? By Anurupena Sutra. Okay, we can solve very easily. Yes? Yes or no? Right. So this is our today's section. If you like the concepts, please like it and comment and subscribe.